In this tutorial, I'm going to show you how to factor a quadratic that doesn't have a middle term because it's been zeroed out. And we call this the difference of squares because subtraction occurs and it eliminates our middle term. But let me go ahead and show you what I mean. For instance, what you're used to seeing when you're looking at a quadratic, if you think back to Algebra 1, you're used to seeing something that looks like this. You have a times x squared plus b times x plus c. Now this is what we're used to looking at, right? We have three terms in a quadratic. But notice on both of these we only have two terms. And notice what's missing is the x, right? We have an x squared in both of these, and we have our constant, our c value in both of these, but we don't have the b. And that's because the b has been canceled out. Because we have a situation where if we were to write this out as two binomials being multiplied, what we would actually have is we'd have x, and one would be plus some number. So it's going to put a number sign, and one would be minus some number, which would cause the middle term to cancel. And when something cancels out and becomes zero, we just leave it off. So this actually has three terms, but the middle term is 0x. Now, when you approach a problem like this, in case you forgot how to do this, I'm going to go ahead and go over some steps. I'm going to show you this more basic one over here on the left, and then we'll go to one that I think may mix somebody up because we have a prime number as our coefficient for our leading term. So on this one, the easy way to do this is you just want to find the factors that make the perfect square for the coefficient of a. In other words, a is always the value that's in front of x squared. So this is my a value here. I'm going to circle it. And if you don't know what numbers will make that a perfect square, you can actually use your calculator to check it, right? Because you know me, as I tell you in class, a lot of times I don't memorize all these math facts, but I know the processes on how to be able to find my answer. And so what I'm going to do is I'm just going to simply take my calculator and I'm going to take the square root of 16 and see, is that a perfect square? So to do that, I'm going to go ahead and I'm going to hit my second button and I'm going to hit the x squared button, which gives me a radical symbol that you can see right here. And I'm going to type 16 inside of it. Now once I hit enter, if it's a perfect square, it's going to give me an integer. It's going to give me a whole number. So notice I hit enter and it tells me it's 4. And that tells me that 4 times 4 gives me 16. So I'm just going to draw some arrows from here, and I know that 4 times 4 gives me 16. Therefore, I can go ahead and start preparing to write my answer just by knowing this. And so I'm going to go ahead and get my two binomials ready. And what I'm going to do here is I'm going to take one binomial and write another beside it. And I know that I'm going to have one of these 4's right here. In this first one, this is going to be 4x. And in this second one, I'm also going to have 4x. Now, because it has no middle term, I know that the middle term cancels, so therefore I'm going to make one of these plus some number and one minus some number, just like the idea I was telling you about up here. Now, what we need to find now is we need to find what two numbers can multiply together to give me the c value, right? So I'm going to go ahead and get my calculator. Once again, I'm going to hit second and the x squared button, right? The x with a little 2 on top, x with an exponent of 2. And I'm going to put in this value of 81. So let me go ahead and put in the value of 81 and hit enter. And notice it gives me 9. So okay, 9 times 9 gives me 81. That's my c value. And so I'm just going to simply go down here and branch it and say this is going to be 9 times 9. One of the 9's is going to go over here. That's the positive 9, right? So this was plus 9. And then one of the 9's, I'm going to make this one negative. This is going to go over here where we had minus 9. Now I know that it has to be a positive times a negative because notice this is minus 81, right? And a positive times a negative gives us a negative value. But I also knew that it was going to be that case because we had no middle term. But this is how we solve it. So really straightforward, doesn't take a lot of work. You just got to know what number multiplies to itself to give you your first term and what number multiplies to itself to give you your final term, your c value, in the equation ax squared plus bx plus c. Now let's look at one that's not quite so simple and maybe a little bit frustrating initially when you look at it. So for instance, on this one, we have 5x squared minus 125. So once again, what you want to do is you want to say, well, is this a perfect square? And if you didn't recognize it, that 5 wasn't a perfect square, it's not a problem, right? Because you can throw it in your calculator and just verify that it's not. So I'm going to go back to my calculator. I'm going to hit second and x squared to get my radical. And then I'm going to put a 5 inside of it, and I'm going to hit enter. Notice this gives me this random decimal strand, right? 2.23606, and so on. When I see that, I know it's not a perfect square, and so we are not going to be able to find two numbers that multiply to give us 5. So what we're going to do at this point is we're going to go ahead, since it's not a perfect square, and we're going to see if we can actually factor out this value from both of these terms right here. So since we know that 5 is not a perfect square, we're going to go ahead and see, can 5 be factored out of 125? And if it can, we're going to factor it out of both of these terms. So I'm going to go ahead, I'm going to grab my calculator. Since we already verified that it's not a perfect square, I'm going to go ahead and take this 125, and I'm going to divide it by 5 and see, can it go into it? And it does. It goes into it 25 times. So since I know that 5 can go into itself and 5 can go into 125, I'm actually going to go ahead and factor it out before proceeding with this problem any further. Now I know 5 will go into 5 one time, and so this is just going to leave me with x squared. So underneath it, I'm simply going to write x squared. And then we know that 5 will go into 125, according to our calculator, negative 25 times. So I'm going to go ahead and write on there minus 25, because it's a positive being divided into a negative. Now, what I have to remember is that we just factored out a 5. In other words, I just divided 5 out of both terms. So we can't forget about it. We have a value of 5. And so what we're going to do is just write it outside of these parentheses that I just put around x squared minus 25. Now, what that does, since we remove that 5, it makes this very easy for us to go ahead and continue to factor it. Now, if I wanted to continue to factor this, I'm going to go and write my factors out, because anytime I have one that's just x squared and a perfect square at the end, it's going to give me two factors, one plus, one minus, just like we had over here, x plus something, x minus something. And so I'm going to go ahead and write my x plus and my x minus. And all I have to do at this point is find out what two numbers can multiply together to give me 25. Now, most of you probably already know that, but if you're that person like me who has trouble memorizing times tables and things of that sort, I would just go ahead and go to your calculator, and we would just go ahead and hit second and x squared, type in 25, hit enter. Notice I did put a positive value. Do not put a negative sign in that radical, right? We're not dealing with imaginary numbers in this particular topic right here, right now. But once I go ahead and put square root of 25, it tells me that it's 5. And so basically this is, we get 25 by multiplying 5 times 5. One is positive and one is negative, because they have to cancel out the middle term. So I'm going to take the first 5, that positive one, and write it right here. And the negative one, I'm going to write it right here. And then I'm just going to make sure that I don't forget that I have this 5 over here that's on the outside of parentheses. And since we now have written this quadratic in here as a product of two binomials, right, that are being multiplied together, I just simply bring that 5 on the outside because I already have a parenthesis there. Now, if I were to multiply this all back out, it would turn back into what we started with, which is 5x squared minus 125. But this is our final answer. We have fully factored that particular quadratic.